Here, innovation is a way of life. We think big, start small, fail fast, and learn even faster. Technology unlocks a world of meaningful insight. From a sea of data, we can recognize patterns, solve complex problems, and enable the government to formulate effective policies.
We work in an agile, bold, and collaborative environment here, so things can move very quickly. But we share a common purpose, that is, building tech for public good.
Diversity in our teams is key to opening our minds to different possibilities and driving innovation. On our journey, there are many uncertainties and unknown dangers to navigate.
To stay on course, we stay connected with our users and stakeholders to ensure smooth deployment and adoption of our technologies.
In cybersecurity, we test systems, processes, and people for vulnerabilities. Starting with limited information, we collect small pieces to solve the puzzle. This requires a deep understanding of tech and an even deeper understanding of people.
During my internship, I had the chance to work with a person with visual impairment. I realized then that even though digitalization benefits many, we have to ensure that no one gets left behind.
It's meaningful and a privilege to help nurture the next generation of leaders in tech. I've also gained much from mentoring and engaging the younger generation of tech talents. GovTech has changed over the years. We'll continue to evolve and empower Singapore in this age of rapid transformation.
Cyber defense isn't about removing the functionalities and benefits of tech. It's about arming ourselves with the knowledge and awareness to safeguard what's important to us.
We go beyond our work desk to get in touch with the people. We learn through connecting with them. This is how we improve. People are at the heart of what we do.
GovTech is a family that builds bonds beyond work. I've come across many who have dedicated themselves to mentoring and helping me grow as a person.
It's rewarding to see my family and friends benefiting from something I have worked on. I'm humbled to have the opportunity to do my part and improve their lives.
Smart Nation isn't a vision with a finish line. It's a mission to always strive to be better. How can we push the boundaries a little further and make lives a little better?
Our motivation comes from improving the lives of the people. Yours, mine, our friends, and family, and the generations that come after. We believe that there's an exciting journey ahead, and this is only the beginning.
Hi everyone, good evening. Great to see everyone here today again. Thanks for joining us tonight. So I'm Joyce, and together with my colleagues, we run the StackX DevRel work here in GovTech. So some of you might have seen the really great video that we played earlier, and that was just a look into what is working at GovTech like. So for those of you who have missed it, you can check it out via the YouTube link that I'm sharing in the chat right now. And so don't worry, of course, this was filmed in accordance to IMDA guidelines. So now we are very pleased to have the Center for Strategic Infocomm Technologies, or CSIT, as our co-organizer for this meetup. CSIT will be sharing their expertise with us too. So we hope that all of you are looking forward to this session as much as we are. So before we start, we would like to run through a couple of house rules that are up on the screen right now. So do note that this webinar is being recorded. The VOD link will be shared with you later, and you can also join our StackX Telegram group to make sure you don't miss it. And we ask that your questions be kept to the topics presented today so that we can keep the session meaningful. And finally, please feel free to ask and upvote questions throughout this whole webinar via the Q&A function that you can see at the bottom of your screen. And do try to avoid posting questions in the main chat because our speakers wouldn't be able to take questions from there. And once again, we are very, very excited to have both GovTech Engineering Productivity and CSIT speakers share how Open Policy Agent or OPA can add value to your work. So the first sharing is by Shane So from CSIT on securing microservices with Open Policy Agent and Envoy. The second presentation will be from Darryl Siu, our GovTechie, who will be bringing you through administrating a compliant Kubernetes cluster with OPA Gatekeeper. And finally, last but definitely not the least, we have Magdalene Lee from GovTech as well, who will be talking about policy as code for painless role-based access control. So before we invite our speakers to share, here's a very quick intro on us for all the new attendees tonight. So we are now about 3,000 strong, and our work can be broadly classified into the three areas that you see on screen: products, services, cyber, and governance. So on the product side, we have over 700 developers who implement products for WOG, which is whole of government, and develop strategic national products. We also have capability centers in digital services, sensors and IoT, data science and AI, cybersec, as well as infra. So the product team also manages this whole of government infrastructure, from our move to commercial cloud, to data centers, and even to the issuance of devices to all of us public officers. The next group, services, is actually the biggest of the three, making up more than half of our staff strength. And they play a very important role in managing technology in over 60% of government agencies in Singapore. And moving on to cyber and governance, so GovTech is actually the sector lead for cybersecurity in the government, and the Chief Information Security Officer sits in GovTech. So to ensure that all the work that we do is safe and secure, our governance group sets ICT policies and guidelines across the government. And next slide. So really to engage and connect with developers, engineers, and techies like yourself, we actually formed the GovTech StackX community in 2019. So if you have not joined yet, you are very, very welcome to scan the QR code on screen to do so now. I'll also share the link to join the StackX Meetup community. So this is where we share the latest info on deep dive sessions with government and industry professionals who share on a really wide range of tech and tech-related topics. So updates on our latest StackX meetups will also be shared with our community members. So this platform is a really, really great way to stay informed about our product and engineering news. And next, I'm sure that you'll discover the Dev Portal contains content that's very useful. So if you visit us, you will discover the products that we've developed. And this includes National Digital Identity, API Gateway, DevOps products, and documentations that you can actually try out. So you can also check out our community page, where you will find the VODs of our past webinars, as well as blogs by our GovTech teams. So the Dev Portal is now in the beta stage, so we ask for your patience as more information is being onboarded. And if you have any any feedback, we would really love to hear from you as well. So okay, next, we would like to give a really quick shout out for an upcoming live streaming event where you can learn more about what goes on behind the scenes at GovTech as we bring to life our mission of engineering digital government and making lives better. So inside GovTech Live Chat is a series that features our GovTechies working in different roles and from very diverse backgrounds. So they will very candidly as well share their work and lives inside GovTech. You will also get to post your burning questions to them during the live session. So do join us at LinkedIn on 15th of July, 4 p.m. So to register and indicate your interest, you can just scan the QR code on screen. And I'll also share the link later in the chat as well. So in any case, during this period especially, we would still love to support the tech community. So we have close to 400 positions available for both contract and perm. So whether you're a software engineer, DevOps engineer, or BA, you should be able to find some interesting roles here. And if you know of any friends who may be keen or have been displaced during this time, please also share this with them. So we are finally at the point that everyone has been looking forward to. So let's welcome Shane, an engineering manager from CSIT, to share about how monoliths were broken up into microservices with OPA and Envoy. So Shane, the floor is yours.
Great, thanks Joy. Okay, let me get my screen share going. Okay, does this work? Can you see this, Joyce? All right, great, awesome. Hope everyone is having a good evening tonight. My name is Shane. Once again, I'm an engineering manager of the developer platforms team over here at CSIT. And tonight, I'd like to talk to you all a little bit more about securing microservices with Open Policy Agent and Envoy. Okay, so let's get started. So very naturally, the question you might ask is, who are we, right? CSIT, or the Center for Strategic Infocomm Technologies, we are an agency in the Ministry of Defense that builds technologies to safeguard the national security interests of Singapore. Our team in particular, we build various platforms and infrastructure that support a wide range of mission-critical operations. And these are very, very unique national security problems, such as in counterterrorism and computer network defense. Naturally, with all that, right, working with such highly secure, highly regulated mission-critical systems, it brings about very unique engineering challenges. So most notably, we work almost exclusively in classified and low-trust environments, where complex access control and audit logging are required, even for internal APIs. So we are concerned about things like insider threats, someone malicious actor who might be able to operate from within the network, which is why we are more concerned about security and access control even in the internal services, perhaps more so than many other organizations. The next other thing is that, and I suspect it's true for many government organizations, we are increasingly modernizing, increasingly having more microservices, but we still have a fair number of monolithic legacy systems running on VMs. Actually, either that or even maybe certain analytical workloads that are harder to, a little bit more technically challenging to move off virtual machines at this point. So it creates a fair amount of, a bit of a heterogeneous environment that we also have to work with. We have all these challenges, and yet we need to have API security that's easy to implement and easy to reason with. So for this, we look to two technologies that we'll talk about in greater details tonight. One is OPA and another is Envoy. So what is Open Policy Agent? So OPA is described as a lightweight general purpose policy engine that lets you specify policy as code and to use APIs to offload policy decision making from your software. Okay, so what this means, right, is that if you look at the diagram with me here, you have a request that comes into your service, but in this case, your service doesn't make any decision about access control. Instead, it defers to Open Policy Agent, running perhaps as a sidecar. You fire a query, and OPA returns you with a decision, allow or deny. So that's what we mean by offloading policy decision-making from your software to OPA. And how OPA makes these decisions is that it can refer to its own set of policies, written in a language called Rego. We'll look at that in a second. This is what we mean when we say policy as code. Okay, that was Open Policy Agent. The next component here is Envoy. Envoy is described as an open source edge and service proxy designed for the cloud native application. So in our purpose, right, we are using Envoy specifically as a service proxy, and we are using it to delegate authorization decisions to Open Policy Agent, and then allowing or denying requests to the service based on OPA's policy decisions. Okay, if that doesn't really make too much sense, no worries. I think the next diagram here would show you how all the pieces fit together. Okay, one thing to note, I'm going to page back a bit here. If you notice over here, the request hits the service and then the service defers to Open Policy Agent. This is a little bit more of the canonical way you might use Open Policy Agent. When we use it together with Envoy, right, we are interested in the incoming HTTP request hitting Envoy first. And then Envoy is the one that then checks with OPA whether this request should be allowed through. So in some sense, Envoy acts somewhat as a gatekeeper in this case. If Open Policy Agent says allow, then Envoy would then forward the the request upstream to the service. If OPA says denied, then Envoy might choose to return a 403 forbidden, for instance. So naturally, for this to work, teams are also expected to deploy Envoy and OPA alongside their services that they intend to protect. And the nice thing about this arrangement, right, is that if you already notice that the service here can just simply assume that any request that arrives to it is already authorized as per Open Policy Agent's policies. So it's actually a very nice separation of concerns, and this is something I'll elaborate a little bit more later on. Okay, to kind of make things a little bit more concrete, I've prepared a sample project at the GitHub link over there. For today's presentation, I'm hoping to kind of run you all through the major components of this sample project. Okay, so everything is defined as services in the Docker Compose file that you can just Docker Compose up. The first service of interest here is this service that we're interested in protecting. So in this case, we use HTTP bin as a mock service. So that's what you see highlighted over here. The next interesting service here would be Envoy itself. And one thing that we should note, and something that might appear a bit unusual, is that instead of just using the Envoy image as is, we chose to build the image. And if you look at the Git repo, what it does is to run like an entry point shell script that does, in this case, pretty basic environments variable substitution. In our context, right, we actually found that this was extremely important to really simplify adoption. We found that the Envoy configuration can actually really indeed be quite complex, and the documentation at this point isn't really the best as well. Yeah, so internally, the custom Envoy image that we maintain does a lot more than this environment variable substitution. It puts in additional logic that's a bit more internal to our use case. But in this sample project, the few environment variables that we care about, things like service name, service port, really is just telling Envoy what your upstream service is. So the hostname being app is because the HTTP bin hostname is app. Okay, the third and last service in this Docker Compose is Open Policy Agent, as you would expect. We're using a different tag for this Open Policy Agent. We're looking at this OPA Envoy image in particular because it uses this OPA Envoy plugin. Okay, what it does is that it extends OPA with a gRPC server that implements this Envoy external authorization API. Okay, what this means simply is that it's a plugin that allows Envoy to defer to Open Policy Agent for its policy decision making. So another thing that's probably noteworthy here is we are mounting as a volume this policy.rego file. So for Open Policy Agent to do anything meaningful, it needs to refer to a policy, right? So in this case, we define it as a .rego file and then we run it, okay? That's the next thing to look at, okay? This is a toy policy written in a language called Rego. I'll step through some of the more critical parts of this policy, okay? You have a little bit of a boilerplate at the top. This line over here, default allow equals to false, is basically just saying the default authorization decision should just be false. And this is typically a very sensible default that we have in most cases. The next chunk that you see over here, this is called a rule. So in Open Policy Agent, a policy can contain any number of rules. In this case, we have one rule in this policy. This rule evaluates to true when all its expressions evaluate to true. In this case, we only have one expression. So a statement like HTTP request.method equals to get is an expression. This essentially says is the method a get method? Yeah, and if it is, then the whole thing evaluates to true. Essentially what happens is that this then assigns the allow variable a response object. And what the response object is defined here as follows. Bunch of key value pairs. Most notably, we need to have allowed equals to a Boolean true or false. In this toy policy, we also set headers, a custom header called XAuth user, and we hard-coded something like 1234. Okay, and as you see over here already, the policy decision, right, can be a very simple Boolean, true, false, or it can be something more complex like an object. Okay, so once you run this setup, right, you Docker compose up, the next natural thing that you might want to do is to take curl and fire a few requests at it and see how it behaves. So if you were to do, let's say, a curl get, as per the policy we just saw, you expect this request to go through, right? So this /anything endpoint here in particular, it is a endpoint HTTP bin that simply just reflects whatever the request was. So in this case, you'll see that the request now also contains XAuth user, this custom header, because it was injected by OPA and then just forwarded on to through Envoy to the upstream service HTTP bin. Okay, if I were to hit the same endpoint again, but now I use a post, then you see that Envoy would return 403 forbidden. Okay, so I think so far this seems quite sensible. What you saw just now was, as I said, a little bit of a toy policy for demonstration purpose. I'd like to share something a little bit more concrete, a little bit more real world. In our internal setup here at CSIT, we leverage very heavily on OAuth 2 and OpenID Connect, that's OIDC, access tokens for making authorization decisions throughout the organization. So in that case, right, for many of our OPA policy, we would typically have this segment that you see over here. That chunk over there simply just takes this authorization header from the request. So we expect the request to come with authorization header. Okay, and then we have something like a bearer then token. So the step here would split it on the white space. So we just get out the encoded token. And this will use a nice built-in JWT utility that OPA provides to simply just decode the token. Right, so JWT being a JSON web token, that's typically the manifestation of OAuth 2 access tokens, how OAuth 2 access tokens are structured rather. So it's nice to also, yeah, you can use like built-in utilities like that to do this. And then now that you have an OAuth 2 access token, you can actually start using it in meaningful ways for access control. So unlike like just checking, say, HTTP method, we could say that, oh, in the access token, I actually expect there to be a key value for resource access, specifically for my app, a service called my app. And in a list of rows, I expect to see there being a read permission. So effectively in English, is that, does this access token contain a read permission to my app? And if it does, then I would say, yes, come on in, just allow it through. And then for the headers, the custom headers, usually we use this to inject identity information that's contained in our access token. So instead of hard coding something like 1234, we might pass in the user ID that was stored in access token, or we might pass in names or group membership and all. Basically, it's however we define the access tokens to be. Okay, and these identity information is often used for meaningful purposes by the upstream service. Okay. Next, I'd like to share a little bit of a use case I thought is quite interesting. I don't know if this is something that would resonate with a lot of y'all who are techies working in the government, but we have a lot of like very important data sets that run actually very critical workflows that are just stored in Excel files or CSV, dumped all over the place, right? So as a separate ongoing effort, right, we are actually trying to move a lot of these files into a headless content management system, a headless CMS. Okay, for those who are unaware, a headless CMS is very simply something that provides a UI, usually for non-technical users to manage content in the underlying database. They might do so in like a Google Sheet kind of style, but all these changes are validated and ultimately stored in the database. Then the second part that the headless CMS typically provides is actually a set of APIs for other services to interact programmatically with this database. Okay, so an example of what these APIs might look like, right? So suppose, okay, in this case, I cited directors. That's actually a very common free and open source headless CMS. The docs, these are taken from the docs. So imagine that you might have a collection of any kind of items. In this case, you have a collection of articles. So automatically the headless CMS should also generate endpoints like /items/articles for which you can post to create new articles. You might also have an endpoint where you can query for articles by IDs, for instance. So very typical CRUD or CRUD type APIs here. But however, right, the built-in access control is actually not flexible enough for our needs and does not support our access token definitions. So what I mean by this is that it might not support the use of certain claims, like we expect to see the resource access, roles, all these kind of things. So instead, what we can do, right, is really to use Envoy and OPA, slap it on top of the headless CMS, and then use that to secure access to the headless CMS APIs. So a policy might look like something as follows, where now I check for things like, do you have the read role? If you have the read role, you can do a GET request. And in particular, you can do a GET request to state endpoint. This rule essentially means you allow querying of articles if you possess a read role. And quite similarly, you might say you can only create an article if you have the write role. Then you can do a post request and so on. So it's this idea of like using Envoy and OPA to very quickly and effortlessly secure any upstream services, any upstream APIs that might not have sufficient access control built into it. Okay, I'd like to round off the presentation as well by just very briefly sharing about what we like about OPA and what we like about Envoy. Okay, so starting first with OPA, a big reason really is managing policy as code. There's this concept of policy as code found to be a very, very elegant one. As you saw, like you had a glimpse at what a typical OPA policy might look like. It's written in Rego. It's fully declarative. We found that to be very easy to read, very easy to reason with, fairly easy to write. I mean, there's a bit of a learning curve, but it's not too bad. And also, OPA provides pretty nice unit testing facilities as well. So all that's really, really good. This concept that I alluded to just now about decoupling policy decision-making away from policy enforcement, that is also very, very powerful. We found that this allows us to have authorization logic being written outside of the service. So it becomes very discoverable. So you know that it has to be in a .rego file, instead of having it being peppered all over the code, which is something I think a lot of us could relate to. And this separation of concerns is very empowering for developers as well, because now they can just focus on writing business logic, write the application logic, assuming authorization is handled. This might be very useful for when you might have a more junior developer who you want to abstract away some of the access control nastiness from, so that separation of concerns, very, very, very useful. OPA deployed as a sidecar also means that policies can be reloaded, OPA can be restarted without affecting the underlying service. So this is also really quite nice for when you have access control policies that might change quite dynamically. Okay, so if you think about how Open Policy Agent kind of resides in a decentralized fashion across the various services, it is actually really nice that OPA also provides some kind of centralized management features. I'd like to highlight two of it. One is that of a policy distribution via what it calls a bundles API. So this allows you to basically distribute policies. And this is very, very useful for when you have certain universal policies that's true organization-wide. So, for instance, you might have the IT security team. Instead of writing IT security policies in prose that gets misinterpreted 100 different ways, perhaps they could be writing IT security policies as code. And that's something that can be easily imposed just by distributing policies that way. So it's an idea that we're toying around with at this point. Something that's a little bit more concrete that we also use quite a bit here is the collection of decision logs. So what the various OPA agents can do is that it can ship logs to a centralized server. And this is actually really nice. the fact that it's also decoupled, right, means that you get your decision logs as cleanly separated from application logs, and that's actually incredibly powerful. If you have like a SOC type function in your organization, those guys would love things like this. Okay, so that's OPA. Next would be Envoy, right? You saw just now, right? Like we have this external authorization filter that we use quite heavily. So these filters are essentially sort of like modular plugin for Envoy, if you can think about it that way, that implements very common functionalities for observability, for logging, and so on. I'd like to highlight another filter that we actually use quite a lot internally. That's the JWT authentication filter. So I'm not sure if some of y'all caught it earlier on, but you saw how the OPA agent basically just took the access token as is, assuming it's trusted, assuming that it's valid, and then it just decoded it and used it. That's actually dangerous because it's actually important for at the service level to also then validate the access token. So you want to validate that it's not expired, that it's really intended for you, that it came from a trusted source, all the fun stuff that actually no one should have to worry about or implement. So thankfully, all this is nicely built into Envoy. Once again, a very nice feature that we like that's Envoy versus some of other more common, say, proxy solutions. There's also this idea of Envoy somewhat like future-proofing us. So to motivate this, right, I have to describe like how we are actually handling our east-west traffic today. A lot of our service calls still will go through an API gateway, which allows us to provide certain functionalities like traffic control and logging centrally. But we also know that this is something that we might eventually have to move out of. We might need to move perhaps into a more service mesh kind of architecture where services are calling each other directly as opposed to through the gateway. More and more functionalities have been moved away from the gateway into Envoy sidecars. And it still is a very popular service mesh technology that can be used as a control plane. So the point I'm trying to make here is that it still itself already uses Envoy, which is nice. So our experience, our familiarity with Envoy will immediately translate to potential architectural changes that we'll adopt. So that's the future-proofing part of it. Okay, yeah, so I understand it was a bit of a whirlwind of information. I hope that was interesting to you guys. Before I end off, I'd like to make a very quick shout out for CSIT. We're hiring software engineers and various other technical positions. In particular, I'd like to highlight that if you're interested in the kind of platforms and infrastructure work that we do here, I've linked a specific JD there that I hope you guys would check out. The really nice thing about working with the developer platforms is that you have a very unique opportunity to create this kind of disproportionate impact on the organization. So I highly encourage you guys to check us out. Okay, and I don't think I have time for questions at this point, but I believe there's a combined Q&A towards the end of the session. But as always, you can feel free to reach out to me at any of my contacts over there if you want to talk more or you have any questions. Okay, with that, I'll hand it back to you, Joyce.
Thanks very much, Shane. It was a really insightful sharing from CSITs as well as your perspective, as well as the various advantages of all these technologies. So to all tuning in to our StackX meetup, please feel free to submit any of your questions for Shane or our subsequent two speakers via the Q&A panel. So next up, we have Darryl, Associate DevOps Engineer with GovTech, who will talk about how the whole of government platform as a service makes use of OPA Gatekeeper to enforce a variety of requirements. So you're up, Darryl.
Hi, good afternoon, no, good evening, everybody. Hi, today I'll be sharing with you about administering a compliant Kubernetes cluster with Open Policy Agent Gatekeeper. So Gatekeeper is a solution built on top of Open Policy Agent to help enforce policies in Kubernetes. Through this short sharing, I'll talk about what Open Policy Agent is, what Gatekeeper is, and what Kubernetes is. I'm mindful that not everyone will understand every concept over here, so I'll do my best to make sure that everybody walks away with a bit of something today. So before we begin, I'd like to tell you who I am and why I'm here. My name is Darryl. I'm one of the engineers at Container Stack. So Container Stack is a platform as a service built for the whole of government on top of Kubernetes. The primary purpose of Container Stack is really to abstract away the management of the underlying infrastructure from the building of application. usually as agencies, you'd like to just build your application and containerize it and have it going. But we know that there's a lot more than that, right? As fellow engineers, we know that there's the operations aspect of it, there's the compliance, there's monitoring, there's a lot of that. So container stack is meant to abstract those away. So OPA, among the many other tools that we use, help us to create an environment secure enough and compliant enough to host government applications. I've been with GovTech for about 1.5 years, and my interest is in automation, which explains why I do what I do. So an overview of what I'll be going through today. Firstly, the platform requirements for container stack. That will quickly help you understand why we're using OPA, as well as after that, I'll be going through with you the Kubernetes architecture. That'll give you a perspective about how we're going to inject Open Policy Agent into Kubernetes after that. And then we'll go through a bit about our implementation experience here at Container Stack. So this is the Container Stack platform requirements. To start off with the platform requirements, just like any other organization, the first big one will be security and compliance, right? The platform must be compliant to regulations, and the platform itself must help agencies to be compliant to regulations. I mean, when you put an application with us, or when an agency puts an application with us, we have to help to make sure that everything is compliant, running, secure. So obviously, the platform has to be secure. That is just, that is what it is, right? Well, a platform is also shared by multiple users. In fact, in the government context, every project is sensitive. So not only does it have to be protected from outsiders, from external adversaries, it has to be protected even from each other. So that's why project isolation is another big requirement. The third requirement, which is often overlooked, is really about convenience and flexibility, right? I think as engineers, I hasten to say, I'll be hesitant to say that we love security. We need security, and we often dislike the inconvenience that surrounds this very critical word, right? That's why as engineers ourselves, we understand and we dislike the inconvenience. That's why when users use our platform, we want to make sure that they are only restrained to the extent that they're required and not more. So they're only restrained to what is needed, and they're able to execute everything else perfectly. So to understand what Open Policy Agent can do for Kubernetes, I'll first give a quick overview of what Kubernetes is. First, Kubernetes is a container orchestrator. So a container orchestrator helps to orchestrate containers. I think it's quite pretty self-explained in the name. But one way to look at it is that unlike running containers in your own local machine, with the help of a container orchestrator, you can basically abstract away a lot of management items. For instance, all you have to do is tell Kubernetes, that you want 5 containers, and you don't have to think about how Kubernetes is going to place the containers in the separate nodes. You don't have to care about the uptime. You don't have to care about the networking. And if a node or a server were to go down, you shouldn't have to worry about that as well, because the orchestrator will make sure that the container is redeployed on another server. So that's what a container orchestrator can do for large scale deployment. The next thing is that the Kubernetes stores the cluster state in the etcd key value store, which is right here. So if you wanted to tell Kubernetes that you wanted 5 containers, these instructions will be stored over here. The definitions of it will be stored over here. Now, Kubernetes has an API server that does CRUD on the etcd. So today, if you told Kubernetes that you wanted 5 containers, the instructions will hit the API server, and then the API server will store the instructions on or the definition within the etcd. Now, if a node wanted to find out whether they needed to deploy a container, they will call the API server. That's the read operation, and they ask the API server, should I be deploying a container on myself? And if that is true, then they will deploy a container to themselves. So the API server is kind of like the brainchild, and the etcd is where they store all the manifests or the definitions, the instructions. So everything is represented as an object in the etcd. So everything, the nodes, the containers, the networking, the load balancing, everything is stored as an object in Kubernetes in the etcd. The users, the RBAC, everything is stored as an object. So the Kubernetes will actively ensure that the entire cluster, everything in here, follows the desired state, which is the etcd. If we were to tell the etcd that there should only be 2 containers in the cluster where there's 5 currently running, Kubernetes will resolve that and make sure that it downscales to 2. On the other hand, if we told Kubernetes we needed 100, then it will resolve that. So the desired state is always stored inside the etcd. The state is here, and the desired state is here. So the state is pretty important, right? Because anything that the state says goes. The state, the etcd, it is a source of truth. So if you're wondering how Kubernetes process that CRUD, since it's so important, it actually goes through a variety of steps, starting from handling the HTTP, and then they do authentication, authorization, mutation, object schema validation, and then to etcd. This is quite a long process, but for the purpose of what we're going to talk about today, the validating admission is where the important parts are going to happen. At this phase, the validating admission will call several webhooks to decide whether or not it should proceed to etcd. And if you have been listening to what Shane has been sharing just now, I think you'll be quick to come to the correct conclusion that this is exactly where Open Policy Agent will be useful, right? Because Open Policy Agent takes in a request on event, and then they evaluate the request to decide whether or not it goes through. So back to the entire Kubernetes API flow. When the request comes in, it goes to, once it hits the validating admission, Gatekeeper will be called. So it kind of looks like this, right? When etcd is important, something has to protect it. And one of the things that we use at Container Stack is Open Policy Agent, Gatekeeper. So it'll just call the webhook, and then we'll evaluate. If it goes through, then we're going to let it go to etcd. If we fail it, then it's not going to go to etcd. The etcd is important. We have to protect it. So to give you an idea of how, or rather to give you an idea of why we use Open Policy Agent and how it's useful in Container Stack, I'm going to give you a few examples of the definitions that are inside our cluster or environment. So an illustration of where Open Policy Agent will be useful. So here we have a pod definition. I'll go through with you how the definition is like, because I'm aware that not everybody will be familiar with Kubernetes. So this is a definition for a pod, or I think another way to put it will be a container. It is nearly synonymous. It is not. There are some slight differences, but for the purpose of what I'm explaining today, a pod is a container. So here we have a definition of a pod, or a definition of a container. Its name is Hello World. It runs as a user 0. Its name is, again, the container name is Hello, and it runs the image BusyBox. So at first glance, it may seem to be quite a reasonable pod. If you're experienced, you quickly say, no, there's a big problem over there. The big problem is that it's running as root, and that is very, very undesirable. There are 101 reasons why one should not run a container as root. I don't think I'll go through a lot as to why we don't run a container as root, but generally, I think in most organizations, this will be unacceptable. But there is more to that, isn't there? If not, we won't be using some Open Policy Agent. Right. The next thing that is there's lesser expected is that there's no labels or annotations to it. So in Kubernetes, typically you have labels and annotations. For those who are unfamiliar with what it is quite equivalent to tagging in cloud resources, like your AWS tags and your GCP tags is quite synonymous to it. And sometimes, or rather in our case, we really want tagging to be present to identify the application. That is quite important as well. Maybe another thing that is less obvious to somebody who's not too familiar with it will be the image, right? Mostly we don't really care where an image comes from. In this case, it is BusyBox. But in this case, the image is taken from a public registry. We can't verify the trustworthiness of the source. We don't know where it's from. An agency user could just put any other image over here, and we won't be able to tell whether it's safe to run. The tagging is not specified. It could be the latest version, or definitely in this case, it will be the latest version. So when the version changes, you'll be getting another image version, which may not be what you intended for it to be. So again, generally, a lot of these things, there's nothing wrong with it if you're doing your own private development. But when you're running a whole of government platform as a service, these small little things becomes a bit more important. Right, so that is a pod definition and the few problems with it. But I mentioned just now that Kubernetes is, they store everything as an object. So a pod is one of them, a container. Another would be a load balancer, right? When you declare a load balancer in this case, what you're actually doing is you're telling a cloud provider that we want a load balancer out here for you. So in this case, we have a service named My Service, and we're spinning out a load balancer. You may notice that there's something weird about this load balancer, mainly the external IPs, right? For for those of you who are familiar, 8.8.8.8 points to quite a famous DNS server, right? And the problem with putting an external IP over here is that it's actually pretty okay in a normal cluster, but when you're inside a multi-tenanted cluster or a cluster that runs many projects at the same time, putting an external IP actually intercepts the traffic. And you can imagine what a huge worry it will be if you have another customer that's intercepting all traffic towards this particular important IP address, right? That is not good at all. And that is a big problem when you're deploying a load balancer within Kubernetes. Maybe something that is a little less obvious would be the source range, right? You won't see any load balancer source range over here. And by default, when that's not specified, we are opening this load balancer to the entire world. Again, nothing wrong with that generally, but we wouldn't want to see that inside a huge platform that's running applications for the whole of government again. So I'll go through some policies that we've implemented to address some of the concerns that is highlighted over here to show you how Open Policy Agent could be helpful for a Kubernetes use case. Okay, so just now I mentioned about how we don't really want images to be picked off any random public registries, right? So this policy in particular limits the type of the registries in which we can pull the image from. In this case, we have one from a random from a specific AWS account, and then we're allowing certain images from docker.io, and we're allowing all the images from gcr.io. So down line by line, you'll see that the first step, the first line, we are actually pulling in the definition. So we just now when we went through a definition, that is the definition that Open Policy Agent Gatekeeper is looking at. And then we'll look at whether we are satisfied with the image, right? So in this case, we'll look at the repositories, the parameters. These are the parameters. And then we check whether the container image provided starts with this repository. In this case, if any of them satisfies this case, it's going to return a false because not any satisfied. So as long as it hits if it fulfills any of this criteria, it is a false, and we're going to exit from here. So for Gatekeeper Open Policy Agent, a violation happens when it goes through all the way, right? So if it doesn't violate, we're going to have a false and we're going to exit. And if it does have a violation, we'll reject it with a violation, and then we're going to return an error message. So just to give you an idea of how that will look like, we have two pod manifests over here. The first is just one with BusyBox, and the other is we're using from gcr.io, which in the previous slide, I've said that it would be whitelisted, right? So when you try to apply something that's rejected, we're just going to tell you, nope, we're not going to allow it. We are allowing images from the following repositories, and otherwise we're going to allow it. So this is a simple case in which we want to whitelist certain image registries, and we don't want customers, clients, or tenants to randomly pull from any registry. So the next thing is required labels or the required taggings. I think it's quite straightforward given the explanation I've given just now. So again, we'll look at whether the object has the labels, and we go through what are the required labels. In this case, it's at kubernetes.io/name. If it's missing, we're going to give it an error message. If it's not, then we're going to go through with it. So again, between the two policies, between the two definitions, one with labels and one without labels. Again, of course, if you apply the one without labels, you're going to get this very unhappy message. And then if you do apply one which has labels, you're going to let it get created. And lastly is the policy for CVE 2020-8554. By the way, I forgot to mention just now, to this date, this vulnerability has not been addressed by Kubernetes. So I'm not sure how many ways there are to resolve this vulnerability because it's really meant for a multi-tenanted platform. But this policy is critical for us in order to ensure that we're not allowing our tenants to do man in the middle to each other, right? So again, the only difference between the one which is rejected is one that specifies the external IP, and the one that is not, that is accepted will be one that doesn't have the external IP. So just like that. So it's quite an enabler because without this policy in general, basically our tenants will be subjected to quite a bit of danger, right? And as a platform, we cannot allow that to happen. So I think we'll share, right now I'll share a bit more about our implementation experience with Open Policy Agent, why we love or why we love Gatekeeper in general, why we love Open Policy Agent in general. The first, I think, is most obvious, which I've demonstrated, is that it permits very, very fine detailed policies in Kubernetes without unduly constraining users. I mean, one way in which we could have prevented users from creating a man-in-the-middle exploit is to just tell them, you're not supposed to create it, right? We'll not give you the permissions to do so. If you want to do it, you have to do it through an interface with us. And everybody loves that, right? They love that bit of red tape in which, as an engineer, you have to first write a request A and then send it to Officer B, who has to go and initiate Operation C, right? And then after that, everybody in the process gets upset when somebody misses an alphabet or so. So that is not what we want generally when we are looking at developing. So it prevents unduly constraining users, and it's an enabler for multi-tenanted Kubernetes environment. We want everybody to be able to define their project in the way which is suitable for them without us telling them no unless absolutely necessary. So that's one of the key reasons why we look at Open Policy Agent as an enabler for us. I think the next big thing, which I think most of you can agree, is given that something is open source, there are plenty of ready-made policies available out there. Some of the policies which I shared just now are available open source, others are not. Of course, the more complicated it gets, the more likely you are to that you have to write your own policies. That is unavoidable, but I think that gives us the flexibility, right? If it's something that is necessary, somebody probably would have written it. If it's something that is necessary but it's not written yet, you could be the next one to write it. So that is pretty important. And the third thing, which I think a lot of DevOps engineers would agree with me, something close to the heart, right? As a DevOps engineer, nothing makes you as happy as seeing something in code. I think there's a few reasons behind that, but one of the reasons why is because you have basically immortalized the process. Or in this case, you have immortalized and enforced compliance. It's not just written in Word documents now. Now anything that you write enforces a certain compliance. So that is a really, really huge thing for us. But of course, Open Policy Agent is not just a bed of roses and all. There are a bit of difficulties with that. The first one is that Rego is not Turing complete. I remember when we first started with Open Policy Agent, it was quite a bit of simple stuff like the one that I shared with you just now. But then we got really excited, right? The sky is the limit. There are endless possibilities. We can secure our clusters in all sorts of ways. Policies are everywhere. And then we totally forgot to fine print that Rego is not a programming language, right? So I remember when we spent hours and days rejecting that truth, trying to figure out how to do things like recursions and for loops, trying to create the perfect policy that really gives you the maximum amount of flexibility with just the minimum amount of compliance. That was quite a painful thing because it yielded nothing but disappointment. Yeah. So Rego is not Turing complete. Therefore, OPA is not suitable for every use case. It is very, very comprehensive, but there is a limit. The sky is not the limit. Rego is the limit, right? The next hard lesson is that policies are compounded. I'm not sure whether any of you have caught it, but just now when I shared about the two policies, one in which we prevented people from creating a pod unless there are text, and the other where we have images whitelisted. Those two policies are actually compounded. So if I were to run the code again with both policies, in fact, both pods or both examples will be rejected, or all the examples will be rejected, because just because one policy passes it doesn't mean that every policy passes that, right? So imagine when you have 30 to 50 policies within your environment. Those policies are going to add up, they're going to compound, and eventually when you add one policy, you're going to break a lot of working stuff if you don't do integration testing. So the third hard lesson that we learned was that integration testing is important. You can't just test one policy at a time. You have to test a whole bunch of policy at the same time. So these are the three hard lessons that we learned. Hopefully this will be helpful for all of you that are trying to think about doing policy as code as well. So that is administering a compliant Kubernetes cluster. That is how we do it at Container Stack. Yeah, thank you very much. If you wanted to find out more about Container Stack, that is our link for careers at EMP. That's our link also. And if you want to contact me, exchange information, engage in discussion, or receive feedback, you can contact me at the LinkedIn link. I'll be happy to connect with you. Yeah, that's all for me. I don't think we have any time for questions at the moment. Joyce?
Yeah, perhaps we can leave the questions because we have a good list going on. So perhaps let's leave the questions for the combined Q&A after Magdalene's session. Thanks a lot, Darryl, for your sharing about the platform requirements and your experiences, of course. So once again, to everyone, do send any questions you have for our speakers in the Q&A panel. We are still taking in all your very, very good questions. And now, may we get Magdalene, our senior software engineer from GovTech, to show how role-based access control can be painless. So please go right ahead, Magdalene. Magdalene, you are on mute at the moment.
Yes, I forgot that. Thank you. Hi, panelists, attendees, techies, and engineers. I have a very brief presentation today on how you can use OPA as an authorizer for APIs. So you heard a lot of Kubernetes stuff, all really fantastic. What I'm interested here is in securing the API endpoints and how you can do that in a policy as code service itself. So here we go. Yeah, we have two use cases for the front end and the back end. Everybody knows what OPA is by now, but nobody asks why is OPA. OPA is not the Outer Planet Alliance from The Expanse. It is 100% protomolecule free. It is not Korean for that. The good thing about OPA, it gives you really, really fine-grained controls. It's like this fine as you want to make it, or as coarse as you want to make it, but you can make it really fine. The really good thing about OPA is that you can do policy as code. So what I mean by policy as code is that you can commit to a PR that's just entirely made out of OPA Rego files. So why is that important? That's important because if you are running a Kubernetes, complete Kubernetes repo, everything as code in one mono repo, and then you decide you want to change the policy, right? The authorization policy. And you have 3 stages to go through. You have the PR, so you merge, then you have a container, it sits in dev environment for 1 day, then it gets promoted to QA environment. Then after that, it gets promoted to production environment, or if you don't practice continuous delivery, your policy change will hit in the next release, which is next month, which will hurt. So don't deploy code changes, deploy policy changes. Why is that so important? When you deploy policy changes, you can make it happen a lot faster, a lot faster, because you can just change the Rego files, it gets bundled, you dump it into the serving place, and then your OPA server itself can pull the policies as a live policy. So the downtime is like as short as your policy pipeline, so maybe 15 minutes at most. Yeah, okay, so that's that. There were some questions earlier about how you can do an audit trail. And the good news about an all policy repo is that you don't see any changes such as, oh, you know, I'm going to change this handler, I'm going to change this API endpoint, I made some changes in how things behave in the backend. No, it's just Rego file from one state to another. And that is the best thing ever. Yeah, so that's that. Why is OPA? There is a very simple setup that I use. We have a UI workload. Basically, we run ECS Fargate because Kubernetes is a lot of overhead. So what we just do is just use OPA only for API authorization and for the UI guarding. We have a CI system that does the OPA policy pipeline push. When changes are made to Rego files, they are tested, committed, and pushed and bundled into a HTTP server where they can be pulled from OPA server itself. OPA will pull the live policies, and then you will be able to use them as soon as that happens. Yeah, how it works together is that there's an application backend which will provide the RBAC information. You will also provide a proxy for the UI workload to receive the UI guard or some UI metadata about what kind of widgets can be seen. We'll see that in one of the examples later. So this is how it's a most elemental, simple, straightforward use of OPA as a pure API authorization UI guard CRUD data that you can use and consume. All right, so our demo topics today is backend authorization with OPA, as I mentioned. I mentioned that OPA is very fine-grained. So if you make an OPA request, the OPA itself is a HTTP server. So your backend can send HTTP requests to OPA, and that will be translated as an OPA input. You can make a request like a HTTPS OPA endpoint, HTTP orders, and a put. So this put is really special. It's an OPA rule. So you can make rules for every single request. We will see why that's useful later. And we can use this pattern to make verb-based authorization for every single verb in your routes in the backend. The other use case of OPA is in the front end as a UI guard. What do I mean by UI guard is that sometimes you might want to hide or show UI elements in the front end that are related to how a user interacts with it. So for example, if you have a store manager in a store, they would have a lot more privileges than maybe a regular employee who is not a store manager. And they will get additional controls and widgets that they might want to be able to interact with. So without a UI guard, you might have to hard code it manually, which is really painful, very unpleasant. You have to cater for all the different changes and permutations instead of being told by this authorization server what you can do. So the purpose of the UI guard is not to actually guard the API interaction itself. That's what the API authorization is for. The purpose of UI guard is to give the user a really cohesive and fun experience, smooth experience, that they don't end up clicking on a button that seems to be functional and then they get, fault treat or fault one from the backend. So that's what UI guard is. Okay, those CRUD permissions can be consumed in the UI with route hooks. So for example, for those who are familiar with front end or do full stack work, when a user enters a route, we are able to fire off route hooks. Like for example, for React, there's use effect. We can fire a API call to get some CRUD permissions. So that's a lot of talking. Let's go right to showing instead of just talking. I'm going to change my screen share to show some very simple OPA Rego. This is all declassified on my personal device. And over here, this is actually kind of like my pizza store. Yeah, it's a Mac's pizza store. So we have several roles. If you turn your attention to this side of the screen, on the right panel, we have some roles which are store manager, general manager, and a customer. So a really interesting thing is that if you are a store manager, you might also be a customer. Just like undercover bosses, you might want to go to a branch and buy some pizza. So the wonderful thing about OPA is it doesn't necessarily need to exclude or negate any of the roles. So yeah, that's that. We have several predefined constants here. Like Shane earlier, he has authorized or allowed. I also follow this convention. So over here, this is returned as a JSON with a Boolean yes or no thing. That's really useful. I have some other utility functions, which is the GM role. So this is a utility function where we are able to tell if this user, based on their RBAC information, if you look at the RBAC information, this is populated from the access control table or the users table. We can do select star from user.access or something. So just basically just pulls out a whole amount of mapped key value pairs. Okay, now, yeah, we can write tests for them. So it's really handy. You can write a unit test straight away. And we are able to do a demo on the endpoint. So over here, I have a endpoint called orders. So this is, for example, used when a person using the system is sending an API request to orders to put an order, to adjust an order. And in this use case, we have the backend auto-generating. This is a backend generation to inject additional metadata into the OPA payload. We have some path. Basically, this is what is received from the backend that they're going to forward to the route handlers. In Express, this would be something like orders / store ID. So we are able to see that over here, we will authorize the GM role to be authorized at all times through a short circuit. And otherwise, we can look through some of the authorization. We can ensure that it's on the correct path. We have the correct method, so you don't get wrong orders coming in. For example, circumventing put with a post request or a patch request. We can check the entity types based on some traversals. We are also able to check the user roles that the person currently has. So we can do that all and prove it with tests. So we can write a lot of tests, which is great because if you work with a lot of authorization or RBAC stuff, working with decorators, working with a lot of other authorization frameworks, you just end up with a lot of difficulty in testing your RBAC sometimes. So everything's in Rego. It's very clean. We are able to run tests as well. So this is the API site testing. Yeah, so I have written a lot of tests. Oops. Yeah, so we can very much clearly determine that all the tests are passing. It's very deterministic, very unambiguous most of the time. That's for using the put authorization in the backend. Yeah, so I will now show the more interesting part, a more unconventional part of using OPA as a UI guard. Earlier, we have a panelist that showed that OPA can return any kind of arbitrary JSON. And of course, if you return CRUD permissions, these are all arbitrary JSON as well. We can have some default permissions. This is the orders Rego for the UI. So it shows how a user can interact with a Rego object in the UI. It's proxied through the backend and returned to the front end fired from route hooks. So we can send permission roles. We can send all kinds of data based on what they are. I'm not going to go through all of this because it's actually pretty repetitive. It's Rego logic, which is you can read on the policy documentation area. But basically, you just get a whole bunch of CRUD booleans, and that's very useful because I will show you on the presentation side how it can be used. Yeah, so here we are at the UI guard site at Mac's Pizza Store. We have several branches. Here we are looking at the orders for Brooklyn 99 branch. We have several orders. In the green section, we have the view that the general manager can see as a global God mode entity. They can edit and they can soft delete some orders. But for example, a store manager is not allowed to soft delete any orders. They are only able to edit orders. So in this case, we can see that the delete button is missing. It's because in the RBAC UI guard return, there is delete equals to false. So it's that simple. Okay, so now we've gone through two use cases as UI authorizer and backend authorizer. We can talk about the downsides. You heard a lot of good stuff about OPA, but there are a lot of real downsides to OPA. Some of it is insufficient documentation. Yeah, OPA has a very high contextual overhead. So if you are completely lost after 1 hour, yeah, that's also my first hour with OPA. One thing about OPA is it's also very GIGO, garbage in, garbage out. It's like a very sharp knife. If you don't know what you're doing, you cut everybody up and cut yourself up. So that's one problem with OPA. Yeah, and the other thing about OPA is it suggests authorization. So we saw earlier that we can return true or false based on some Boolean values and judgments from OPA. But the fact is OPA doesn't really enforce anything. It just suggests to your backend or whichever place that's in charge of authorization that you shouldn't allow this. So you can take OPA's advice or you can just skip it. Yep. And basically that's it for me at the end.
Thanks a lot, Meg, for the very, very insightful sharing as well as pretty candid presentation, I would say. So I hope everyone, again, as much as we did from our speakers, deep dive into OPA, especially since it offers so many potential benefits as well. So we do have quite a lot of questions in the Q&A panel right now. So perhaps since Magdalene, you were the last one to speak, can I direct you to one of the questions that you'd like to answer?
Sure thing. I'll speak about the audit trail and auditing. So there was a question about how OPA can provide some auditing, or how do you get auditing with OPA? I mentioned in my purely Rego only repo. So in this repo, everything is done through pull requests. All the state changes in the policies are visible in the pull requests. We know who did what. We can see who approved what. So this is one of the factors that contributes towards auditing OPA policies.
Okay, thank you. So I hope that Gerald, that was your question, right? So I hope that answered your queries. If not, you could add on in the Q&A panel as well. So perhaps we can have Darryl as well. I believe there's a pretty interesting question that came in for you too.
Okay, yeah. So this question, how are you guys handling unwanted drift in OPA policies? Like, for example, if someone accidentally deletes something, does the cluster reconcile the changes with respect to the policy config in your source control? I think this is a pretty important question. The question covers the theme, right, which is how do you handle compliance in this aspect? I think the one thing to take note of is that OPA is not the only solution. It's not the end-all be-all when it comes to compliance. There are a lot of other factors involved. Firstly, who has access to change the policies? Who has access to your Kubernetes cluster? And how are you supposed to audit the changes that are within your Kubernetes cluster? So for us, we don't believe in letting people make anonymous changes. Of course, I think that's true for everybody, right? One of the things that we practice is GitOps within Container Stack. That is that all your Kubernetes manifests, they are defined within your Git repository. So if you wanted to have a new policy, you put the policy within your Git repository, and then we have an operator from within the cluster that will pull the repository. So in the event that there are some unwanted changes to your resources, whether it's your policy, if not for your pods or your containers, whatnot, there is a mechanism to remedy it. So to answer the question, how do we prevent unwanted drifts? So we, through two ways. The first is we prevent people from making changes, making unauthorized changes. And in the event that people do make unauthorized changes, we have a self-healing mechanism to make sure that the changes are being removed. So that's how we do that. Yeah.
On mute. So thanks a lot, Darryl, for answering this question. Siti, I hope that answered your queries as well. So I think we have another question that has been greatly upvoted. So perhaps Shane, you would like to tackle this first.
Sorry, which one's the question?
Okay, let me read it out to you.
The latency one, is it?
Yes, so the one that Vincent actually sent over.
Oh, okay, sure. How about this? I'll talk a little bit about the Envoy performance, and I'll leave it to my fellow presenters to elaborate on OPA's performance. Okay, so for Envoy, we have not done any of our own internal benchmarking or anything, I have to admit. But then based on community benchmarking, on Envoy's documentation, Envoy as a proxy holds its ground compared to very similar alternatives like Nginx, HA proxy, traffic, that sort of thing. But the nice thing about Envoy is that performance greatly depends on how you use it. So I shared a little bit about these filters, right? So I would imagine if you stacked on like, a crap ton of filters and you end up having on your Envoy sidecar do a lot of things, I would imagine that would also add greatly to the performance impact. So this ability to kind of like use the bare minimum as you need and to kind of tune the performance along the way, I think that's something that's quite valuable. More anecdotally, we have not experienced anything that in terms of performance impact that would sufficiently degrade our service to notice, at least compared to the latency of the upstream service. Envoy's latency itself hasn't been anything that's noticeably poor in that sense. So I hope that answers your question, Vincent. Would someone else like to talk a little bit about OPA's performance?
I think within the Kubernetes context, we don't really have a problem with that, even though we have a ton of policies running. I think one factor that contributes to this is the auto scaling, or rather the load balancing. So, I mean, when there are more requests, all you have to do is to increase the number of pods that are running, right? So of course, there are other considerations, like if you have too many policies or if your cache is too huge, how do you handle that? I don't think I really have an answer for that. I guess we do really have to balance between what we feel is important in terms of caching, right? Because you do have to define what kind of data you need within your OPA environment. I think in the context of Kubernetes, you could cache certain types of resources. So we have to very carefully balance that. But other than that, I think if there is a need to scale up the number of open policy agents to fit the number of requests, then I think that is one way that we have to do that. So in terms of performance, we are not really feeling the negative aspects of it, or rather, the cost of that is not significant enough for us to consider doing away with open policy agent as a means to protect our compliance. Yeah.
Magdalene, would you like to weigh in on this question as well?
So this is not really relevant to my use case, so I will pass on this.
Okay, sure. So yes, I guess, yeah, we do have a couple of more questions up ahead. Perhaps our speakers, if there's a question that you really, really want to answer, please feel free to just hop in right now.
I guess I can speak a little bit to some of the questions that I tried to answer by typing. I'm not sure if the audience got a chance to read that. I like Joseph's question on ABAC, attribute-based access control type of rules. I think his question kind of highlighted that this whole Envoy OPA setup and the way we use it isn't going to work for every use case. And we never intended for it to be that way also. It is really meant for that 80% use case where a fair amount of, like, I guess, coarse-grained access control, we can refer to as such, or fairly more simplistic RBAC type of authorization logic can be handled in such a manner. What's the biggest limitation with this particular setup, right, is that if you have any kind of information or data that you need for making a policy decision that cannot be contained within the OAuth2 access token and is not contained with the metadata of the HTTP request, then you cannot rely on this setup solely. So an example would be, in Joseph's case, a rule like the creator of a document can update the document. This notion of who's the creator of a document is stored in the access token. It's likely stored only in the service that you're trying to protect. So what we have done with many of our services that have very similar access control needs, right, is to still implement Envoy and OPA for very coarse-grained authorization logic. That's because we get to benefit from this centralized administration of access control through our OAuth2 authorization server. So we still want to have some sort of centralized management of access control that way. But then we also have to concede and say that, okay, you need to have some deeper service level authorization logic, which will entail running yet another OPA agent that the service calls directly. So in this case, right, the service would be able to provide any additional information that this second OPA agent needs to make a policy decision. Yeah, so that would be a possible way around this issue that Joseph highlighted.
Thanks a lot, Shane. So we actually have a follow-up question from Joseph regarding the first question that you answered. Perhaps can I get Darryl to weigh in on that as well?
I think the question is quite similar to Gerald's one, which is really about regular testing, right? So how do we verify whether the policy is works well with a JSON document? I think that is really a question about test. And in the case of compliance, what you typically want to do is to make sure that your accesses or your permissions are very, very closely defined, right? So rather than having a policy that says accept all except for, or like allow except for, you should be having a deny except for. So that is how I'll go around doing that. I think that is quite that may not necessarily be the answer that you may be looking for. But I think when it comes to writing regular tests, right, that is really how at least that's how we do it from a platform perspective in compliance. So we have a very, very remember when I said that we use Open Policy Agent to have a very, very fine policy, very detailed policy. That's really what we're trying to achieve. So if it doesn't comply, it's going to get rejected pretty quickly. So you're not likely to have a test run for a long period of time. And for us, we have a pretty quick timeout for that as well. So that is the way that we go about doing that.
Got it. So I hope that Joseph and Gerald have their answers as well. So perhaps Magdalene, would you like to take any questions that we have in our Q&A so far? We still have a couple. Thanks guys for submitting your questions.
Okay, yes. So I believe that there was a question about all the route spamming, because we have a lot of route hooks. So we might end up spamming the backend server who's proxying all our UI guard requests. So the solution for that is to do it with a debounce or do it with some kind of time to live with Redux Redux cache in the front end, so that we are able to not spam the backend so much. So maybe, for example, we can have a time to live of 5 minutes for the UI guide in the front end. And that's around the same time as maybe a policy route. So I think 5 minutes is fair. You can do that, but of course, ultimately, the actual acceptance or denial of a API request, for example, if you saw deleting an order for the pizza store, if you wanted to delete an order, the ultimate authority of that would be the allow or not decision in the backend. UI guard is a kind of like a user experience thing. Yes, so I think that answers Joseph's question.
Thanks a lot, Meg. So yes, we have 3 more questions. Perhaps our speakers can help to answer, because I do have a couple of questions from my end as well. So is there any other questions? So our speakers, please feel free to just hop in to answer anything that you want. Okay, so maybe at this point, let me jump the queue a bit and ask some questions that I've had. I guess this is one question that I have for Shane first. From CSIT side, maybe is it possible for you to share some of the adoption rates as well as onboarding process with OPA and Envoy technologies?
Okay, yeah, that's a very fair, actually very important question also. So for Envoy in particular, I kind of shared like how in an attempt to sort of abstract developers from the complexities of configuring Envoy and all that, we build and maintain our own custom image to abstract all these complexities as environment variables instead. So that's one way around it. We found that actually in practice that has helped quite a bit. There could be even like further opportunities to, let's say, auto-inject Envoy as a sidecar on a Kubernetes cluster. This is something that it still does actually as part of the service mesh. That'll be nice because that could even then further abstract the developers away from Envoy. You might not even need to know how to deploy or configure Envoy because it just happens, right? In terms of OPA, it's a little bit trickier. We also do acknowledge that there's a little bit of a learning curve that comes about from learning the Rego language. So more generally, right, the way we do onboarding and the way we support adoption of technologies is to build various cookie cutter projects, as we call them. It actually uses a Python project called Cookie Cutter that essentially provides starter kits, and many of our starter kits exercise various parts of our internal development platforms, including Envoy and OPA. So we actually generate, as part of the starter kit, various sensible OPA policies so that developers have an easier time getting themselves started. Yeah, so this is some of the ways we've gotten around the issue of adoption and onboarding.
Yeah, that's definitely an issue that I'm sure a lot of us have questions on, how to get people using it actually. So maybe can I ask one more question of Shane? So actually, how would you do integration tests?
Okay, yeah, so that's also a pretty common question that we get from our own developers. I think that the question is really more about like, do you integration tests, say with Envoy and OPA? How will you go about doing it, especially in the context of us using OAuth to access tokens so heavily for access control decisions? So as part of this like custom Envoy image that I've been alluding to, right? We do expose as environment variable a way to turn on and turn off the JWT authentication filter. So this is important for integration testing for when you want to turn off JWT validation so that you can mock access tokens. And then you can fire these mock access tokens at Envoy through your service and validate the responses that come back. The reason you have to do this is because if you don't, then Envoy expects a trusted access token for which, unless you have access to authorization server, you wouldn't be able to provide one. So that's a way we kind of enable integration testing. But on testing more generally as a question, I do want to point out that OPA's unit testing facilities is itself quite powerful. So we rely on that quite heavily for unit testing at least of OPA policies. Yeah.
Thanks very much, Shane, for sharing. Yeah, so our speakers, you can hop in. Yes, I saw your hand, Magdalene.
Yeah, so I'd like to hop in a little bit and I'm going to share my screen. You can see the code here. So the really interesting thing about having some testable code is that you can actually change your data. So for example, sometimes you find that something's not right with your OPA return. So you got some weird things happening in your policies and you don't know what's going on. You can actually paste what you're sending to OPA into some of these tests. So for example, I can change all this data payload that I'm sending to OPA into what I'm actually sending in production or my dev environment that's giving me issues. And I will be able to replicate through the tests what is failing. So that's a really interesting use case of the policy as code and having very, very powerful unit testing. You can paste the input for me, because I use it as a HTTP authorizer. I can just paste inputs and then run the test command over here, and then I can see what's failing or how it's failing. But of course, it's also GIGO. If you don't have really good Rego policies written or good tests written, then you might not be able to understand what's going on. So that's one thing about that. Yeah, I'll stop screen sharing.
Cool, thanks. Yes, so perhaps Darryl, can we direct the time to you if you have any other comments or sharing points?
But I think for in the context of Kubernetes, testing may be a bit different because of the way that Rego is written. It is not inserted in the same way that it is for the way that Mac and Shane does so. So one of the tools that we use is the env test library, which is what Kubernetes operators tend to use. So we find that to be quite useful for us, even though it doesn't. I don't think it's serving the use case, its intended use case, where env test is to test the Kubernetes operator code, right? But it is useful for us because it helps us to rapidly do integration testing, where we can test all the policies all at the same time and to quickly return us the results. So env test is the way that we go about for that.
Thanks a lot, Darryl, for sharing about Kubernetes testing as well. So maybe I can ask the speakers if there is any other points that you think would be important for our attendees to take note of. That probably has been covered quite comprehensively in 3 presentations.
I have one point that's really important. So I've been very candid about how difficult OPA is to use, but to be very frank, the pros outweigh the cons, and having OPA on your side is really useful, really powerful. It's worth the pain. Yeah, it's a little bit painful, a little bit, but it's worth it. Like a root canal.
Yeah, that puts everything in perspective then. So thanks very much to all of our speakers. So Shane from CSIT, the CSIT team, and GovTech's engineering productivity speakers, Darryl and Magdalene, for being really so open with sharing all your know-hows. And big thank you for everyone's time to join us today as well. So before everyone logs off, we do have some things that we would like a bit of your help with. Rachel, you can put up the deck now. Yes, so your feedback, as always, is very important to us. So do tell us how this webinar went by scanning the QR code on the left to give us your feedback. I'll also share the link to the post-event survey for those of you who prefer that. And also, we have been going on a lot about how we would be sharing more news about StackX meetups, as well as the VOD of this recording via the StackX Telegram channel. So do scan the code on the right, and I'll also share the link so that you guys can join us and be updated on all of our latest news, as well as this VOD. So thank you very much. And if you have any other questions, you are very welcome to join our StackX Telegram. Another advantage there, because our speakers will be up there for about a week to answer any questions that you have. Yes, so thank you everyone again. Thank you our speakers, and have a good evening. See you at our next meetup.